Magnetic reconnection is the process of disconnecting or connecting the magnetic fields to each other, directing energy into the Earth on the day side and then letting it go on the night side. And the interplay between those two is what produces all the space weather around the Earth that has big effects, can damage our spacecraft, can hurt astronauts, can upset the flow of electrical energy in our electric grid on the surface of the Earth. MMS is a mission with 4 spacecraft that are traveling in formation in an orbit that takes them out into 2 special places near the Earth, one upstream toward the Sun, one downstream away from the Sun. Both of those places have magnetic reconnection. We have never, before MMS, had the ability to essentially run the camera fast enough to catch it as it goes by, to make mini measurements per second. The science payload for MMS is all mounted on a single deck plate, but it consists of some 25 boxes per spacecraft, divided into 3 general groups of instruments. And that's those for measuring fields, electric and magnetic, those for measuring plasmas, and a third for measuring energetic particles. The magnetic field sensors are out on arms that extend away from the spacecraft. They're fixed, but the spacecraft is spinning slowly, about once every 20 seconds. The electric field is quite a bit different. It consists of 4 wires that extend out away from the spacecraft with a ball on the end of each of them that actually contacts the plasma. All 4 of those are spinning around with the spacecraft at this 20-second period. And then there's a third axis that extends, their booms that extend along the spin axis of the spacecraft, both upward and downward, with a probe at the end. So you've got 3 components of the electric field. They can measure everything from up to small wiggles and vibrations of the electric field. There's another sensor called the search coil magnetometer that is just a loop of wire connected to a suitable amplifier and is designed to measure the fluctuations at higher frequencies than you could get with the DC magnetometers. For the plasmas, there are 8 boxes, 2 boxes at each of the 4 points of the compass on the spacecraft. Those are equally spaced all the way around the spacecraft, essentially. That is a real key ingredient for being able to see the entire sky instantaneously without waiting for the spacecraft to spin. Then there's also a hot plasma composition analyzer, 1 per spacecraft. It has a sensor head that looks all around in a 360-degree annulus, sticks out the side of the spacecraft and sweeps out the whole sky twice per spin. It measures the chemical species of the particles. The third set are the energetic particles analyzers, and they are measuring much more energetic particles that are accelerated by the reconnection process. Ultimately, the thing we will be doing is comparing our observations with simulations of the entire magnetosphere as it is influenced by the solar wind coming in, down to the details of what reconnection is occurring. People who do those simulations that try to apply them to all other kinds of places, like in the solar atmosphere, at other astrophysical stars and other objects, and they're very interested in whether those simulations are accurate and reflect reality well. This is going to be the first time we actually bump them up against hard data on what's going on in there. I'm almost certain, I'm very certain, they're going to learn something from that, and the simulations will get better. We're going to measure things at rates that have never been done before, and in places that have been hard to reach or even see because they go by too fast to be seen. So it's going to be fantastic.